Hello everyone, my name is Michael Skivstead, and I'm going to be talking about some of the research we do with the North American Freshwater Turtle Research Group in Texas at Comal Springs. This is part of a large study that spans from Florida to Pennsylvania, and there was part in Mississippi. But before I begin, I'm going to talk a little bit about myself. I'm actually not the lead author on this study. That's Eric Muncher, who isn't here today, but I'm speaking on behalf of all the authors and the whole team. But I'm from California in Orange County. A lot of you turtle nerds out there, you know that that's not the best place to find turtles. We have one pond turtle, and you have to travel about 34 hours out in the desert to get the next turtle, the desert tortoises. I work with both species, but it's always fun to get out to Texas where there's 29 to 34 different species depending on who you talk to. So I get to go out here every 3 or 4 times a year to get to do this research. I was in Madagascar 2 months ago helping with the radiated tortoises there, and I've been going around. I've been pretty busy this summer speaking at different places, so this is an honor to be supported by the SSAR to travel here and speak here. So without further ado, let's talk about this project at Comal. And before we start, we'll play a little bit of a game. You don't actually have to guess, but just to show some of the diversity of the spot we're sampling, do you think this is the site that we're working at, or is that the site? So actually it's both, and the first picture is a little brushed up and Photoshop, but that does display some of the differences we're at this site. So the second picture is of eelgrass, and when we're working here, we're snorkeling and catching turtles, and sometimes it feels like you're in that paradise, and sometimes it feels like you're in a swamp where something's going to come and get you and pull you down. But so we're working in Comal, so this is in New Braunfels in Texas, and this is the headwaters of the Comal River. So it's a spring, it's constantly heated around 70 degrees year-round, which actually affects the turtle population here because they have a year-round spring to feed on, somewhat like in some places in Florida. And then we're also working in the southeastern United States Turtle Priority Area, which was identified in Bowman et al. In 2009, along with 4 others, and then this is within that range. So at Comal, what are we doing? We're obviously working in this 2-mile stretch of river that spans from eelgrass to a nice lush habitat, but to put it into simple terms, we're catching turtles. This is a picture of me with a common musk turtle. So we're doing a mark and recapture study here at this spot, and we're working with 4 different species of turtles, and we're building a database. So that's what we're doing. We're trying to just build a large database over a long period of time. We've been doing it for 6 years, and through this database we can monitor population fluctuations, we can get all sorts of data. We've had about 12 different studies just in 6 years come out of just this site, and just through this database we can monitor different aspects of the population of turtles here. So the process, we're a volunteer-based and science-based project, and the interesting part about this project is it's not just a scientist, it's not a circle of maybe 3 or 4 scientists that are working on this. It's also including citizen scientists, and over the course of the different studies, there are probably about 100 volunteers that come out and do this in different states. Here we have about 20 to 25. Normally every sampling we get about 15 to 20. And so we begin by snorkeling up the river, and it's about a 3-mile stretch of river, and it takes about 3 hours to do. It sounds worse than it is. It's not that bad because you're going pretty slow. But in the end, we catch about 100 to 150 turtles with just 10 to 15 people, and lug back 3 to 4 canoes full of turtles, and the whole time they're just crawling over your feet, and it's pretty cool. But then we bring them back and we process them, and that's kind of the term we use at Comal, which is where we pit tag them, we notch them, and we use the notching and pit tag system. The notching corresponds to Kegel, the 1939 method, to track them, and that's how we're building our database, so next time we go out we can identify the same individuals. So Okay, so the turtles we work with. So I want to spend a lot of time with some of the data that we've already collected, Currently, the next study that they're about to publish, coming out in 2018 or 2019, is under review. So we have some older data, but it's relatively present. So we work with 4 species. We do have the first official scientifically documented record of a yellow-bellied slider in Texas. They're definitely there, but we documented on paper in this study first with that species. And these are the 4 that we see commonly. And we'll start with the common musk turtle, Cernoceros oderatus. And at Comal, this is our most highly marked species. Those of you from the southeast or just the eastern states, you know that these are very common turtles. And we have over 3,000 marked in just 6 years, which makes this, including all of the turtles, the second most number of marked turtles, with about 5,000 turtles marked in the United States. So an interesting part about this is the sex ratio of these turtles. It's about 3 times male biased, which is interesting. A lot of times with this species, we see it's almost female biased in some populations, and it's definitely not 3 times. But we're thinking, because these ones display a different type of sex determination in some species of turtle, type 2, where females are produced at sort of a middle temperature and males are produced at both a low temperature and a very high temperature. We think that it's possible that the sites that these turtles are nesting at are just exposed constantly to heat and no shade, and that we're getting this male biased population. So also, we expect that there potentially, based on statistics, is a population of 14,000 turtles in a 2-mile stretch. And based on the number of new turtles, we get about 150 of these every sampling, and about 100 of them are new every time. And a lot of them are adults. So we just keep continually getting new turtles, which is, it's hard to believe at 14,000, but once you see the sheer load of new turtles, it's possible to believe. So the second species, so it's Pseudomys texana, the Texas cooter. And these ones are second most. We have 1,700 marked. And the sex ratio here is a little bit female biased, and this is because these ones at higher extremes, the females are produced. So we think that if the musk turtles are male biased in that type of sex ratio, at high temperatures it would be males. And these ones are a little bit of a smaller cooter, but we catch a good amount of these, and they're put in our database. So again, we have the next species, Trichemys scripta elegans, the red-eared slider. And interestingly, this is right at the edge of the species range, but it still somewhat counts. And these ones, everywhere you go, you find sliders. In California, where I'm from, we go down to the creek to look for pond turtles, and we find 50 sliders. And here, we only have 300 marked in 6 years. So where they're actually found, they aren't as common, which is pretty interesting, especially when you're from a place like I was struck by this, because it seems like this would be the most common species we find, but it's not. And then the last one we have is the common snapping turtle, Calidra serpentina. And this one you'll see we only have 20 marked, and a lack of specimens to make any statistical inferences, but based on just the ideas of the people working at the study, 20 to 30 is probably all that are inhabiting this system, because we have surveyed it pretty well. But the reason being, the leeches, but this title was a little bit thrown off, because the leeches at this point we don't believe are actually what's causing what we're calling the case of the sick snapping turtle. So you'll see on the top of the head over here of the turtle that there are these large ulcers that are appearing right over here, and the shell is becoming very pitted down, almost like it's been eroded away. And then we also have this heavy leech load. And so they're sick, we can tell. They're very lethargic. And we're trying to figure out why. We've only have 20 marked, and we're assuming that at some point beforehand, some of them died off. When we pull them out, they'll make no attempt to snap. They won't. The eyes are swollen. There are multiple hypotheses as to why this is happening. At this point, we believe that the leech may be a cause, maybe the effect of a cause. Because they're more lethargic, they settle on the bottom. And a lot of people know that snapping turtles get leeches. We counted 580 off of this one, and the next closest in any literature reference we can find is 480. So we have an unofficial leech record on the turtles. But we think it could be golf course runoff, but we don't see this disease in any other turtles, which is kind of, it's throwing us off. It could be something in the water. At this point, we don't know. So if any of you have any experience, please come up and talk to me after. We want to figure this out. And this is one of the studies that I'm currently really working on. So the invasives, just a short little touch here. We remove invasive species when we can. There's the nutria up in the corner, and armored catfish. These ones will compete with native animals. The fountain darter that lives in this ecosystem actually is parasitized by a gill parasite that was carried by an invasive snail. And the turtles actually eat the invasive snails, which the musk turtles eat the invasive snails, which is interesting. And we actually published very recently a study on that. And so it's also pretty fun to catch catfish with bare hands, so that's a little excuse, but these ones are invasive, the armored catfish. So this project is very cool because, as I said, it's not just a group of scientists coming together, it's also citizen scientists. And that's essentially a scientist who maybe doesn't have credentials to start a study, but they're invited to come, just regular people, to come do this work. And it's interesting because it actually adds two main things to the study, which are very crucial. It adds manpower, which is probably the most important. If it was just 3 or 4 people out here, there's no way we'd be processing 200 turtles in a day in 2 to 3 hours, or catching 150 to 200 a day over 3 days. And then the next thing it does is a lot of the people that come out here are from this area. And if they know about the situation these turtles are in, and they're monitoring them, they can talk to people that live near them, and they can educate the community about this population. So what are we doing to help? Well, it's a very urbanized channel. We want to help the turtles, but by building this database that we're building, we can also monitor, say, a population's hit, the snapping turtles, such as the snapping turtles. Is that disease affecting any other species? So we can use this data set, which we're using on turtles, to monitor other species, such as some of these endangered species, like the fountain darter and some beetles at Comal. So lastly, the future, what are we trying to do? Well, we want to continue the study for more than 10 years and just keep it going. The whole North American Freshwater Turtle Research group has been in action since 1999 when it started in Florida, and this site came about 6 years ago. And we want to we're talking to the city about building turtle nesting areas because we don't think that they have the proper nesting areas. As evidenced by the sex ratios being skewed, but also because it's very urbanized and the channels are concrete and they can't really exit the water. We want to make a large data set. We want to continue to expand and get local people involved. We want to figure out what's going on with the snapping turtles, obviously. And really, very importantly, we want to continue to involve local people. We want to inspire new generations of scientists. If this wasn't a project, I wouldn't be involved with this, and it's been really inspiring to be involved with this particular, it's research, and it's interesting because as a young person it's kind of hard to get involved, but this project has been very open about that. And we want to continue just normal people to be able to come out and do some of this and just to learn about the turtles that are coexisting with them. So acknowledgements, we want to acknowledge the City of New Braunfels, Texas Parks and Wildlife, SWCA, Turtle Survival Alliance, and of course every researcher that's come out and made this possible. And then, thank you from the NAFTA team.
Great. Thanks very much. That was a great talk. And thank you for everyone for coming. We're just about done on this session now, but I'm sure that all the speakers